A very good day to Dr. Chu Kim Mei. We are from NCGEM and we will be presenting about Student Online Learning System. I am Janustia Anak Joji with matrix number 86543. Along with me are Adam Daniel bin Rasman 86244, Martina Anak Michael Teo 86598, Nick Azaya Anak Gunung 86729, and Abang Akmal Irfan bin Abang Idris 83019. For today's agenda, we will be talking about Module 1, consists of introduction, team organization, project description, summary of MOV, comparison of alternatives, and total benefits of ownership (TBO). For Module 2, list of resources needed, deliverable structure chart (DSC), use case diagram (UCD), work breakdown structure (WBS), resources cost table, and task duration. For Module 3, revise schedule, revise budget, conversion strategy, risk identification and evaluation of MOV. Short introduction for our project is our team is seizing the opportunity to drive digital transformation in the education sector with an innovative online learning system. Designed to enhance student engagement, streamline administrative tasks, and support diverse learning needs, this solution bridges the gap between traditional and digital education. By integrating scalable data-driven approaches, we aim to create a future-ready learning ecosystem that elevates educational outcomes and empowers institutions to adapt to evolving demands. Our team's organization consists of me, Janisiana Joji, as project manager, Adam Daniel bin Rasman as our system developer, Martina Anak Michael Teo as our quality assurance specialist, Nick Azaya Anak Gunung, technical specialist, and also Abang Akmal Irfan bin Abang Idris as our data analyst. NCGEM came up with this student online learning system is because the traditional educational institutions suffer from a lack of interactive, tailored learning tools, which resulting in low student engagement. Inefficiency in administrative tasks diverts the attention away from instruction and lowers the educator's output. With this system, the engagement and also the inclusivity will be increased. This is because of the use of data-driven and interactive learning methods. Students can learn at their own pace while gaining real-time feedback, making the learning process more dynamic and accessible to students with various learning preferences. The operational efficiency also will be better. This is because automate administrative operations, including registration, grading, and progress tracking. This reduces the administrative workload, allowing the educators to focus more on teaching and student involvement, resulting in increased productivity and more efficient operations.
My name is Martina Anak Michael Teo with matrix number 86598. For the summary of MOV, it consists of four parts. For the first one is desired area of impact. It has three parts: student, operational, institutional, and for the desired value of project, the first one is improvement in quality, better, expanded capabilities, do more, enhance efficiency faster, and appropriate metric. The first one is 40% increase in student engagement, 25% decrease in administrative workload, 20% increase in accessibility to diverse learners, 20% increase in student engagement, 25% increase in personalized learning opportunities, 30% reduction in administrative task time, and for time frame is 6 months. Comparison of alternative consists of three parts. For the first part is maintain status quo, do nothing, alternative A. Continue using the existing LMS or maintain traditional learning management method. For the second part is purchase a commercial LMS, alternative B. Invest in commercial ready-made LMS platforms such as Google Classroom, Moodle, Canvas, or Schoology. This platform come with essential MNS functionality like attendance tracking, grading, content delivery, assessment, and communication tools. For the last part is develop a custom LMS alternative C. Build a customized LMS for scratch or with open source software tailored to specified school needs such as custom grading system, specific learning pathway, or unique assessment type. So this is the table that will explain about the total benefits of ownership and total cost of ownership. Total cost ownership for alternative A, no upfront cost. Alternative B, moderate upfront cost with ongoing listening phase. Alternative C, higher upfront cost for development and implementation. Ongoing cost for alternative A is ongoing cost for manual processes, resource limitation. Alternative B, ongoing cost for listening software update and support. Alternative C, ongoing maintenance, updates, and potential development expenses. For the total benefits of ownership, alternative A, no immediate financial investment, relies on existing methods. Alternative B, improve data management, resource optimization, and streamline communication. Alternative C, tailor to specific school needs, greater flexibility, and optimize data management and reporting capabilities. List of resources needed consists four parts. First one is people, project manager, system developer, quality assurance specialist, technical specialist, data analyst. For the technology, programming software, project management software, facility is software, test site, and others are training. So this is our deliverable structure chart DSC for student online learning system. It consists of five parts. For the first part is initialize and conceptualize. It has business case. For the second one is project charter and project plan. It consists of project charter and project plan. For the execute and control, it consists of analysis, design, testing, implementation where analysis has collection of information system, proposal budget allocation, design has logical design, technical design, testing has test plan, test result, implementation has documentation, and training program. For the number four is close project, final project report, formal acceptance, and for the last part is evaluation project success is project evaluation.
Okay, hi madam. My name is Nick Isaiah, matrix number 86729. So this is a use case. Uh, this diagram is divided into three main type of user: student, lecturer, and admin. Each of these user has specific role and access to particular functionality within the system. So the first one is student use case. So the for students, student can perform several tasks including viewing available courses, enrolling in courses, checking their progress in courses, and viewing the assignment grade, which is linked to the process tracking feature. And secondly, for the lecturer use case, a lecturer can create and update courses, grade assignment, and view submission to access their work. And lastly, for admin use case, their role include managing user account, such as creating new account or deleting inactive one, managing courses by adding and removing them as needed, and generating system report to monitor the platform overall performance and usage. So each user role clearly define interaction with the system, ensuring that their tasks are streamlined and do not overlap unnecessarily. Okay, for the work WBS for the work breakdown structure, so we have a total of seven phase. So the first phase is project initiation and planning. The second phase is hardware and software development, and the third phase is quality assurance and testing. So as we can see on the WBS, we can see the duration, how many days it need to be completed, the start date, and the finish date. We also have the resource name. Okay, as we can see on the slide, so the phase 4 is data analysis and insight. The phase 5 is technical guidance and expertise. So phase 6 is final system deployment and user training. And for the last phase, phase 7, is post implementation in review. So as we can see, the duration, the start and finish date, and also the resource name. Okay, for the resources cost table, uh, the first category is people, so five personnel, so 5,000 for each personnel. So the total cost for people is 25,000. So for technology, we have 10,000, and training, we 5,000, and facility 15,000. So the total cost for resources is 50,000 for this project. For a task duration, so the first phase is define project scope and objective. So the total duration is 13 days. So the second phase, develop a project plan and timeline. The duration is 7 days. For phase three, resource procurement and budget allocation. The duration is 7 days. For the fourth phase, hardware and software deployment, the duration is 26 days. For phase five, quality assurance and testing, the duration is 41 days. So phase six, data analysis and insight, it take about 81.5 days. Phase seven, technical guidance and expertise, the duration is 151 days. For the final phase, phase eight, for phase eight, final system deployment and user training, it take about 34.5 days. And the last phase, phase nine, is post implementation review. It takes about 7.4 days.
Hi, my name is Adam Daniel. My matrix number is 86244, and I'm going to talk about our revised schedule for this project. So at first we have 26 week worth of time, which is equal to 6 months. And now after we have um, to cut like 10% of our time limit. So from the original 26 week, it become 23 weeks. As you can see, this is the original one. The time limit is 26 weeks, and then after the revise is 23 weeks. And next we have the revised budget. At first our budget is 150,000 ringgit Malaysia, and then after being cut about 20% worth of budget, now we are left with 20,000 ringgit. This is the revised budget. All of this should be summing up to 120,000 ringgit Malaysia. That's all from me. Thank you very much.
Alright, my name is Abang my friend the Abang Idris, metric number 8319. Today I'm going to show you our conversion strategy for our online learning system project. So for our project, we basically use the parallel approach. It enables the simultaneous operation of both existing and new online learning systems. So there are reasons for that. So because the online learning system is crucial for students and like instructors to access, submit, and edit additional content, so they must be remain uninterrupted. So if there any issues arises from the new system, so the existing version versus backup, so that's a good thing. Besides that, gradual user adoption is a significant factor because users may not be familiar with the new system, but they can learn it from test from time to time. So over time, when they familiar with the new system, so they can use this new online learning system as usual. So when they feel that the new system is fine, to say at least by now. Apart from that, users tend to increase their confidence in the system. So with that in mind, so when the issues arise, they can complain to the IT department for improvements, adding some missing features from the existing system to the new system. So until the users felt alive when they felt that new system feels like when they're using the existing system in terms of familiarity. Talking about the other strategies that we don't use, let's say direct cover. So the reason why we don't use direct cover, which basically we shut up the whole entire existing online learning system and transition our users to online learning system, the issue is the fact that when there are issues arise and significant faults, that will drastically affect the usage of the online resources, especially for the students and like instructors. So their productivity and usability is disrupted so badly. Yeah, especially when they want to access a certain content, it's literally become inaccessible because of the issues with the systems. Therefore, that direct cover strategy is not suitable for that project. Talking about the phase here, although it's a superior and safer method, it needs more resources, it needs more time, it needs higher costs, so therefore inhibiting any purpose of reducing the cost as stated in the project. So that's why we don't use the passive brush. Oh, not to mention coordinating incremental rollouts can be very challenging. So again, that's why we don't choose that. In conclusion, we use the parallel approach since this strategy is definitely a superior option for our new online learning system project. Alright, so we're now talking about the risk identification, and here is the diagram for the risk identification framework. So here is the table that showcases the risk identified for each pages. So let's start with the conceptualize and initialize, where there is a potential risk that the project purpose and need and are not well defined, which can result in the fall of the project, and the probability is low. Secondly, the developer project charter and plan, where it may not satisfy the needs and expectations of the shareholders, which is probability is very high. Thirdly, the execute and control, where it not accurately identifying the requirements and specifications of the system, which is very low. The fourth part is close project, where the scheduling error and may cause project to be postponed delay, where it changes are the medium. And finally, where evaluate project success, where this may affect the initial memory, which is still very low. And here's the members what we handle each of these risks for each pages. So let's start with the conceptualize and initialize will be handled by quality assurance specialist, where it performs multiple checks on the requirement and project defined incorrectly to ensure the project is going well. Secondly, the developed project charter and plan will be handled by project manager, where it communicates and planning must be established between the shareholders to ensure they agree with the work. Thirdly, the execute and control will be managed by system developer, where they need to make sure they follow the requirement and specification of the system. The fourth one is the close project, where it will be handled by technical specialists, where they need to track the schedules daily and include schedule review in every project meeting. And finally, the evaluate project process will be handled by data analyst, where it should understand and re-emphasize the MOV at each point of the project to ensure that each metric is allocated to the required task. And finally, let's talk about the evaluation of MOV. Our team successfully completed the project with remarkable results, meeting our requirements and adhering to the schedule seamlessly. The project was accomplished within 26 weeks at a total cost of 70,000 ringgits. The achievement is a testament to our team's dedication and ability to deliver exceptional outcomes. Throughout the project, we encountered several challenges and errors, some of which seemed insurmountable. However, thanks to the passion and determination of our project manager, we addressed each issue step by step, ultimately achieving the desired results. Every team member contributed wholeheartedly, giving 100% effort to ensure the project's success. In conclusion, while our team performed admirably, the final result differed from our initial expectations due to adjustments requested by the client. The client's demand for a shorter timeline, 10% cut from initial schedule, and 20% cut from the initial budget, but posed significant challenge. This contrast required us to re-enlist the original schedule and cancel certain aspects of the project's initial plans to align with the revised scope. Despite these obstacles, our team demonstrated resilience and adaptability, ensuring the successful delivery of the project within the stipulated constraints. And that's it from all of us. Thank you for your paying your attention, and thank you for your watching.